Hello, this is my continuation of the 2024 AP Calculus BC FRQs, and we'll be going over number 3 in this video. So, number 3 was our slope field and differential equations one. So it gives us this differential equation, the initial condition, and it tells us to sketch the solution curve. It even reminds us that it needs to go through that initial condition, 0, 4, right? So when we're sketching a slope field, got to make sure, first of all, that it goes through that point, and they even give it to us, so can't really get this one wrong. But anyways, what you're going to do is you're just going to try to follow those slopes and not really have any obvious conflicts with them, but let them like slowly push you along towards your solution curve. And I mean, you can't really get this to be that good. It might look like not perfect, but all that really has to happen is that it can't have any obvious conflicts with the slopes. It just has to look like it works. And I mean, you can always erase it and try to make it look nicer, because I feel like this one is like pushing me up to here, to this level maybe, right? And then this is, but at the end of the day, it's not a big deal. You just got to make sure you don't have any, it goes through the point and it doesn't have any obvious conflicts. And usually this question is just like 1 point. So there we are, that's question A. And for question B, it can be shown that h of t is always greater than 1. For t between 0, for t on the open interval 0 and 5. So we need to find the value of t at which h has a critical point. Okay, so h has a critical point means that the derivative, aka dh over dt, is equal to 0. That's a critical point, or does not exist. That's a critical point. Looking at this function, dh over dt equals 1/2 h minus 1 cosine t over 2. I'm not really sure. Yep, if h is always greater than 1, should not be any points at which it does not exist. So don't really have to consider that for this problem, but keep in mind that critical point means equals 0 or does not exist. In this case, no does not exist. Determine whether the critical point corresponds to a relative minimum, maximum, or neither. Justify your answer. All right, so let's start off with dh over dt equals 0. So that means 1/2 h minus 1 cosine t over 2 equals 0. Now, this will equal 0 at either h equals 1 or cosine t over 2 equals 0, right? Well, h prime of t, always greater than 1. Don't need to worry about this. We're finding values of t as it says in the question anyways. And so cosine t over 2 equals 0. So that means t over 2 is equal to pi over 2 plus 2k pi and 3 pi over 2 plus 2k pi. And the reason I'm doing this is because we're operating on the interval 0 and 5, and I'm trying to keep track and make sure we don't lose any solutions or get any extra solutions on this interval. So now I'm going to multiply both sides by 2, pi plus 4k pi, or 3 pi plus 4k. Okay, well, first of all, that's out of the question. 3 pi is going to be something around 9. There's pi, then 4 times k equals 5 pi. That's also out of the question. So pi. T equals pi is our critical point on this interval, right? So now we need to determine whether it corresponds to a relative minimum, maximum, or neither. Well, we could use the first or the second derivative test. The second derivative test would involve finding d squared h over dt squared, and that might be a little bit more work than the first derivative test. So I'm going to go ahead and just use the first derivative test to determine if it's a relative minimum, maximum, or neither, right? So we're going to see how dh over dt is affected by this critical point. So usually, to help me see how dH over dt is affected, I look at its individual factors. And that just helps me put it together in my brain, you know. So 1/2 h minus 1 is always greater than 0 because h of t is always greater than 1, so that's positive, positive. Now, for values of t less than pi, but still greater than 0, but still t less than pi, so that would be pi over 2 or pi over 3, but when we put that into here, that would go from being like pi over 2, as I said earlier, to pi over 6, and then pi over 2, as I said earlier, to like pi over 4, and then pi over 6. But anyways, okay, look, if we're going for values that are like t is less than pi, that's going to be values at which t is less than pi over 2, right? And we know that in the first and fourth quadrants, cosine is positive, right? So that means it's going to be positive. And then if we're taking values that are greater than t equals pi, then that argument is going to be greater than pi over 2, then it's going to be negative. So there's a relative maximum because the derivative goes from positive to negative. All right. And now for question C. We're just solving the differential equation using separation of variables with the initial condition h of 0 equals 4. All right. So we have dH over dt equals 1/2 h minus 1 times cosine t over 2. So I'm just going to start off by multiplying both sides by 2, just to get rid of that 1/2 real quick. And now I'm going to separate and integrate. This is going to be 2 dH all over h minus 1 equals cosine t over 2 dt. So what I did was I divided both sides by h minus 1 and multiplied both sides by dt. Separation of variables so that I can get the same ones on either side and then integrate. So this is 2 ln absolute value h minus 1 equals, chain rule, 2 sine t over 2 plus c. Do not forget the plus c. I'm going to divide both sides of the equation by 2. And then that's going to give me ln h minus 1 equals sine t over 2. And c divided by 2 still stays as c because it's just a constant. Then I'm going to take both sides of the equation and raise e to both sides of the equation. So then I'm going to get h minus 1 equals e to the sine t over 2 times e to the c. Write that as e to the sine t over 2. Like here, let me show you. Remember, so this becomes e to the sine t over 2 plus c, and that equals this. And I'm going to make e to the c, that's a constant again. C e to the sine t over 2. And the reason I was able to remove this absolute value is because it got absorbed into this constant. So after I raise e to that, after I raise e to both sides of the equation, and then take this big constant out that I get from e to the c, that allows me to get rid of that absolute value. So now I'm going to say h equals c e to the sine t over 2 plus 1. And now, to solve for that constant c, I'm going to use the initial condition. So 4 equals c times e to the sine 0 over 2 is just 0. C e to the 0 plus 1. E to the 0 is just 1. So 4 equals c plus 1. C equals 1 to that side. C equals 3. So h of t is equal to 3e to the sine t over 2 plus 1. And that's the solution to question C. And thanks so much for watching. I hope you guys enjoyed this video, and if you did, if you could consider liking and subscribing, I'd greatly appreciate it. And I'll catch you guys in FRQ 4.